What if leaders could test civilization-scale decisions before making them? In this final project, we build a simulator for climate, cities, economies, migration, health, energy, food, governance, conflict, and technology. So resilience becomes something we can explore, not just hope for. We've reached the point where earlier themes begin to converge. Agentic AI, digital societies, biotech, robotics, climate systems, planetary sensing, and decentralized science are no longer separate threads. They become ingredients for one larger question. How can civilization sense, reason, coordinate, and adapt under stress? Project 30 takes on that challenge. The core idea is a shared decision simulator for civilization-scale choices. Rather than treating climate, cities, food, energy, health, migration, infrastructure, and governance as separate problems, the simulator connects them as one interdependent system. Leaders and communities can ask, what happens if we invest here, regulate there, or face a major shock? AI agents and researchers help run scenarios, compare outcomes, and expose trade-offs. The goal is not to predict one perfect future. It is to create a foresight environment where decisions can be tested before they shape decades of consequences. Modern civilization behaves less like a set of separate machines and more like a living nervous system. A drought can raise food prices, increase migration, strain insurance, and destabilize politics. A shipping failure can limit medicine, energy, manufacturing, and trust. A disease outbreak can reshape work, schools, cities, and diplomacy. The danger is not only the first shock, it is the cascade through connections we do not normally see. Simulation gives us a safer way to test those pathways before reality does. One useful way to frame the simulator is as shared decision infrastructure. Different users ask different questions, but they all benefit from the same capability: testing futures before committing resources. Public leaders can compare policies, investments, and emergency responses. Researchers and DeSci networks can test assumptions and make evidence more transparent. Communities and NGOs can explore local trade-offs in language people can use. Infrastructure planners can stress test systems built to last for decades. AI governance agents add another layer, scanning weak signals and coordinating simulations across domains. The key shift is from one central user to many decision modes. Think of the simulator as a stack, not a single model. At the foundation is trusted data from satellites, sensors, public records, and scientific repositories. That data feeds simulations of cities, climate, economies, populations, and larger world systems. Above that, intelligence systems test scenarios, detect anomalies, trace causes, and recommend strategies. Finally, people interact with the results through dashboards, immersive rooms, and collaborative environments. Each layer has value on its own, but the real power comes when data, models, AI, and human judgment operate as one connected system. From an architecture perspective, the flow starts with trusted data pipelines. Live signals and historical records come from cities, ecosystems, markets, health systems, and infrastructure. Before that information enters domain simulations, it has to be validated. Then AI agents branch the future. They test scenarios, trace cascading effects, and compare trade-offs across climate, mobility, food, health, finance, and social behavior. The important point is that humans stay in the loop. Dashboards and immersive environments turn complex model outputs into choices leaders can question, refine, and act on, with results feeding back to improve the models. A civilization simulator is only as useful as the data people can trust. Inputs may come from satellites, sensors, edge devices, research databases, and economic records. But raw data is not enough. Each dataset needs lineage: where it came from, how it was cleaned, and what assumptions shaped it. Sensitive data must be analyzed without exposing individuals or communities. Models also need independent validation, reproducible methods, and peer review. Public governance keeps access rights, ethical boundaries, and civic accountability aligned with the public interest. Scenario agents act like explorers inside the simulation space. They can generate different futures: optimistic, fragile, disruptive, regenerative, or crisis-driven, and ask what each pathway would demand. Domain agents bring specialized lenses: energy, food, health, infrastructure, climate, economics, and migration. When these agents debate, They surface tensions one model might miss, such as climate gains that increase food risk or economic growth that strains infrastructure. But the agents do not decide. Human experts still judge evidence, ethics, legitimacy, and the final framing of action. No domain acts alone. A climate shock can affect crop yields, water allocation, food prices, insurance losses, migration pressure, and energy demand. Those impacts then feed into budgets, employment, hospital capacity, and public trust. Health shocks and governance failures create similar chains. A disease outbreak can reduce labor supply, disrupt schools, strain hospitals, and change mobility patterns. By linking these models, the simulator turns isolated forecasts into system-level insight. It shows where a decision creates ripple effects, trade-offs, or unexpected risks. A city digital twin becomes the local anchor for a much larger simulator. In a fictional coastal megacity 2042, leaders can test flood walls, transit redesigns, zoning changes, hospital capacity, energy upgrades, and heat strategies before committing real money. The model combines sensors, satellites, utility maps, service data, and community feedback into one place-specific system. That matters because impacts are uneven. A policy that helps one neighborhood may overload another. When city models connect upward to regional and global simulations, local choices become visible as part of a planetary system. Now imagine the simulator as an environment you can enter. Instead of reviewing a report, leaders walk through possible futures. They compare adaptation, collapse, and transformation, and see consequences unfold across maps, timelines, and systems. This turns strategy into shared experience. Teams can test policy levers together, notice cascading effects faster, and make civilization-scale choices with more context than a dashboard alone can provide. A resilience simulator is useful only if it turns scenarios into choices. So we measure more than survival. We track how fast systems recover, where redundancy exists, whether adaptation is possible, who carries the burden, and what ecological costs appear. Strategies are then compared across multiple objectives, not reduced to a single score. One plan may improve energy stability while weakening equity or public health. The outputs should make those trade-offs visible through maps, hotspots, intervention portfolios, and forecasts. The guiding question is simple. Under uncertainty, what actually strengthens civilization? By 2050, the biggest value may not be better prediction alone. It may be better coordination. A civilization-scale simulator could help governments, scientists, companies, and communities test choices before crises cascade. Cities could stress-test infrastructure. Health and food systems could prepare for shocks. Climate plans could reveal shared consequences, not just local wins. In that world, simulation becomes a new decision layer, helping society anticipate, adapt, coordinate, and regenerate with more confidence. Project 30 brings the full journey together. Trusted data, advanced models, AI agents, digital twins, and immersive interfaces become a foresight environment for civilization-scale decisions. The goal is not prediction for its own sake. It is wiser action across crises, climate, supply chains, health, and governance. Your next step is to turn these patterns into a 2030 to 2050 venture thesis.